Welcome back to my channel. Remember, in my last video I explained the meaning of a set, then the various ways of writing a set, which is the roster method, the property or rule method. Then we also saw the meaning of infinite and finite set. Then we proceeded to seeing some notations on sets, notations like the singleton set, the null or empty set, the equality of two sets, equivalence of sets. Then we also saw the meaning of subset and power sets. Today, as I promised in the last video, we are going to start off from the universal set. So what is a universal set? The universal set is the set that embraces all the sets under consideration. The universal set is usually denoted by U. Okay, this is an example of a universal set. If we are given a set A which is equal to 0, 1, 3, and set B equal to -2, -1, 4, and set C equal to -3, -1, and 4, we can form the universal set by adding all the elements of A, B, and C as one set. That is, the union of the three sets in consideration will yield a universal set for the three sets. Here, Q will be equal to, which is our universal set, will be equal to -3, -2, -1, 0, 1, 2, 3, 4, and 6. That is the addition of these three sets, 1, 2, 3, their union. Okay, so we'll proceed to second example. Given that A is equal to S is a 100 level engineering student, then set B, then S is a mechanical engineering student, then set C equal to S. S is an engineering student from the University of Benin. Next page. From the above three sets, 100 level engineering student, a mechanical engineering student, and an engineering student from the University of Benin are all under one umbrella, which is engineering student. It therefore follows that our universal set will be X. X is an engineering student. Okay, so see this note: when a universal set is formed by the union of some given sets, we call the universal set the least possible universal set. Observe that in the first example under universal set, the U so generated from the union of A, B, and C was -3, -2, -1, 0, 1, 2, 3, 4, and 6. That is the least possible universal set for A, B, and C. Of course, this is the least possible universal set for our set A, B, and C. Look at them. So these are the three sets. The least possible universal set we can get from them is this, just the addition of the 3, 1, 2, 3. See, -3, -2, -1, 0, 1, 2, 3, 4, 5, 4, 6. See that all these elements here are here. So the universal set contains our set A, B, and C. However, we can decide to extend the universal set as U equal to X. S is an integer. What are integers? Integers are negative and positive whole numbers. Okay, if you look at this universal set, you will discover that it covers integers, but here 5 is not in it, right? So let's continue. So we can extend the universal set by adding other elements like 5, 7 to the right, and adding other elements like -5, -6 to the left. That set will become a set of integer, and we'll discover that set A, B, and C will still be contained in that universal set. So we call this later set of integers as an extended universal set for set A, B, and C. Okay, so set of numbers. Here we are going to see the set of various types of numbers. The first we have to consider is the set of natural numbers. The set of natural numbers denoted by n is given as n equal to 1, 2, 3, 4. Okay, so these are natural numbers, which is our counting number for 1, 2, 3, 4 to infinity. Look at this example. Given that the set a equal to x is the first 5 natural numbers, write a in the roster method. Okay, so here we are told that a contains s and s is the first 5 natural numbers. The first 5 natural numbers are 1, 2, 3, 4 and 5. This will become our answer. Then let's proceed to the next set, which is the set of integers. As defined above, integers are negative or positive whole numbers. The set of integers denoted by z is given as z equal to from negative infinity to 0, then from 0 to positive infinity. That's a set of integers. And note, they must be whole numbers. Okay, let's see this example here. Given that the set q is equal to y, then y is the number of integers between -9 and 2. Next page. What is q? The integers between -9 and 2 are -8, -7, -6, -5, -4, -3, -2, -1, 0 and 1. These are the integers between -9 and 2. So if we were to count them, we'll see that they are 10 in number. Thus, our set q is equal to 10 if we were to write it using the roster method. Okay, note, natural numbers are contained in the set of integers. Thus, n is a subset of z. Okay, so here we are saying that the set of all natural numbers can be found in our integers. You know, integer consists of both positive and negative, but natural numbers are from 1 to infinity, and from 1 to infinity can still be found in what our set of integers. It therefore follows that n is a subset of z. Set of rational numbers. What are rational numbers? Numbers that can be expressed as fraction, that is in the form a all over b, are called rational numbers. The set of rational numbers denoted by k is given as this expression. Notice that a and b must be member of our integers, which means here is an integer, here is an integer. But b must not be equal to 0, because if it is equal to 0, a all over 0 will make our expression to become infinity, which is meaningless. Okay, so this fraction, this a all over b, is a terminating or recurring decimal. All right, terminating the decimal example is if we have 2 all over 5. We see that if we evaluate that 2 all over 5, we have 0.4. Of course, that is a terminating decimal. There is an ending. Example of recurring decimals are 10 all over 3. 10 all over 3 will give us 3.333. So that is a recurring decimal. You see that the 3 is continuous. Okay, so for a number to be called a rational number, it must be in this form, and the decimal must, and when you evaluate it, the decimal you will obtain must either be terminating or recurring. Note, if b divides a without a remainder, then the result will be an integer, of course. Thus, integers can be found in rational numbers. Again, since we can assume that integers have a common division by 1, that is, all numbers having 1 as a denominator, we say that are contained in the set of rational numbers. That is, z is a member of q. Example is -7 all over 1, which is equal to -7. This is a rational number. This is an integer. It means that since all integers are assumed to have a common denominator 1, we can say that all integers are members of this set of rational numbers. Okay, so we'll proceed to the next one, the set of irrational numbers. The set of irrational numbers is denoted by I. Irrational numbers cannot be expressed as fraction or the form a all over b. Also, their sequence of decimal numbers does not have a predictable unique array, that is to say, they are neither terminating nor recurring. Examples are the square roots of non-perfect squares, as in root 2, root 3. If you evaluate this, you will discover that the decimal there does not have a predictable pattern. This is root 3, root 2, root 3, and so on. Also, numbers like this exponential, we have 2.718, the number is continuous. This is an example of irrational numbers. Also, this pi here, I know in your physics you were taught that pi is equal to 22 all over 7. Of course, that is approximate, but however, pi is an irrational number. Okay, so we'll proceed to the next one, the set of real numbers. The set of real numbers consists of the set of natural numbers, integers, rational and irrational number. It is denoted by arrow. Let us consider the real number line. This is the real number line, which is this. This is the real line starting from 0, 1, 2, 3 to the right. Then starting from 0 again. All these are negative, minus 1, minus 2, minus 3, down to minus infinity. There are numbers which are fractional numbers or decimal numbers between these intervals 0 to 1, 1 to 2, 2 to 3. The same thing here, 0 to minus 1, minus 1 to 2. There are numbers in between. So this line is referred to as a real line. Okay, we're going to see some stuff from this real number line. Here, if we decide to take just the whole numbers, which is the positive and the negative numbers, we say that it will form a set of integers, and the set of integers can be partitioned into positive integers and negative integers. So from minus 1 to minus infinity, whole numbers lying between minus 1 to minus infinity, they are called negative integer, and whole numbers lying from 0 to positive infinity, they are called positive integer. So it therefore follows that the set of integers is a member of the set of the real numbers. Also, if we are to start from 1, positive 1, down to plus infinity, the whole numbers between 1 to positive infinity, we see that we obtain natural numbers. It therefore follows that the set of natural numbers is a subset of the set of real numbers. Okay, so here we see that minus 4 all over 1, this is an irrational number of which the result is minus 4. So it therefore follows that these numbers, rational numbers, are still a member of this set of real numbers. Also, the same thing here, between 2 and 5, their middle is 5 all over 2, which is 2.5, of which this is a rational number. Okay, so proceed to the set of irrational numbers. Root 2 will fall somewhere here, which is here, and the decimal there is non-terminating, neither non-recurring. Okay, so here this is an irrational number. Exponential will give us 2.7, so it will fall somewhere here, of which this is an irrational number. It therefore follows that the set of irrational numbers is a subset of this is a subset of the set of these real numbers. Okay, So from the definition of real number set, we can say that the real number set is the universal set for all the set of numbers we have considered. So numbers like natural numbers, integers, rational and irrational number, they are all subset of the set of these real numbers. We proceed to the next one, complement set. What is a complement set? Given that A is a set, the complement set of A is written as A prime or A power C. A prime is the set that contains the element in the universal set that are not found in A. So any set that contains elements that are not part of this A, they are called what? Complement of the set A. Okay, we'll consider an example. Given that our universal set is equal to integers and A is equal to negative integer, find A complement or A prime. Solution: the universal set given is a set of integers, which is it comprises of both negative and positive integers. Thus, if A is negative integers, it means A prime must be positive integers. You know, A prime is what is in the universal set that is not in A. So if negative and positive integers is our universal set and we are told that A is just negative integers, it means A complement must be positive integers. Okay, we'll consider another example. Given that U is equal to S, Y, Z, P, Q, R, X, T, and A is equal to S, Y, Z, and B is equal to Y, Z, P, R, find A complement and B complement. Look at the solution here. A prime will be, since our universal set is S, Y, Z, P, Q, R, S, T, and our A is S, Y, Z. So any elements that are here that are not here is what will be here. Here X is here, so we don't write S. Y is here, so we don't write Y. Z is here, so we don't write it. So we notice that P, Q, R, S, T are what are in this universal set that are not in our set A. Thus, our A complement will be equal to this result. Similarly for B, B contains Y, Z, P, R, right? Okay, so B complement will be elements here that are not here, of which the result is this. There is something I want you to note. Note that the complement of a set is the set that is a complement, then complement again will result to our set A. Here is some questions I would like to leave with you. The first there is, what is the universal set and can be generated from the outcome of the toss of a coin? Then the second there is, from the definition of the normal system given above, which of the following statements are true or false? So here you are to show which of these statements are true or false from A to F. Okay. The last one there is, given that our universal set is equal to 1, 2, 3, 4, 5, 6, and A is equal to 1, 6, then B is equal to 3, 4, 1. Find A complement and B complement. So this is what you have to do. Thanks for watching. Make sure you drop your answer in my comment section.